So, welcome. Welcome to the 20th Annual Green Tour. My name is Neil Bonsgard, and my pronouns are he and him, and I'm a program manager of the Energy Challenge, which is a program of the Environmental Center.
Hey, everybody. All right, so we are actually going to kick off this panel discussion with a quick intro to what zero energy is with Scott Leonard from Energy Trust of Oregon. He'll just give us a little bit of background so we're all on the same page as we kick off this conversation. So Scott, I'll let you pull up your presentation here, and we'll circle back around with this crew in just a minute and start some of the questions.
That sounds good. Thanks, Lindsay. Okay, I'm going to be sharing my screen. Okay, are we seeing that? How's that?
Yeah, we can see that now.
Great. Okay, thanks. Hi, I'm Scott Leonard, and I'm the program manager at Energy Trust of Oregon. And so we run a residential new construction program. Energy Trust, if you're not aware, is funded by the utilities, Pacific Power and Cascade Natural Gas in your area, and a few other utilities, PGE, and also Avista and Northwest Natural Gas. And so the way that our program works is we're basically paying builders to build above code. And so when the code changes, that essentially is the baseline. That's the basis for what you legally have to do in a new construction home. And what Energy Trust does is we try and get builders to go beyond that. And the goal is to pay builders to build above code so they're ready for when the next code changes. And then also pass on those energy savings, the operating costs, onto the homeowner. And so that's the basis of the program. Where we're going to go today is talk a little bit about what we've just developed. And when I say just developed, as recent as developed it in 2019 and are just launching it now in 2020. And this is Energy Trust new construction version of net zero. And I talk a little about energy smart homes, which are some additional technologies that are installed in the home. And so when I say net zero for Energy Trust, there's a lot of net zero definitions out there. But for Energy Trust, for a lot of reasons, but part of it being that we're funded by both gas and electric utilities, and we see a large number of homes, I want to say close to 85% of homes are actually built with natural gas as their heating system. So we wanted a way for all builders to be able to participate in this definition of net zero. And so you can read it there, but the definition is that the installed solar panel is going to offset all of the home's electrical load. So that would be a different equation if you were building a house that was heated by natural gas or a house that was heated by a heat pump. There's some other things to consider when you're talking about the definition of net zero. A lot of people think of, well, what's your energy bill? Are you actually paying something on your energy bill? There's also a distinction to be made the way that you're calculating the energy. So whether it's site versus source. And in this definition, we're talking about site energy. So source energy being that there's energy that's tracked all the way back to the production of the energy. This is the energy that's actually being produced and used at the site. So that's a quick overview of this net zero definition that we came up with. We did a lot of feedback to arrive at this point, and we feel like it's a good starting place for 2020 and for the builders that we're working with. Now, the second thing I'll talk about real quickly are energy smart homes. And what we're trying to do here is get a home so that it's capable of being a little bit more interactive with the utility grid. So there's different appliances, water heaters, think about things like solar systems, things like smart thermostats, electric vehicles, things that are essentially require a lot of power and can be controlled by the utility grid at a peak event, or at a time where the utility decides to turn off the power because of wildfires. So we see this as kind of the future of where homes are going to be going. So we released both of these this year. Okay. So I don't know how many builders are on this call, but for those that wanted to participate and receive incentives for this, there's basically 5 core requirements to get a net zero incentive. You need to be funded through your electric utility, which is an energy trust utility. We really recommend, and this is true of any design process, that you build early and think about what you're doing early. And a lot of things when you talk about net zero need to be worked out really even before the home breaks ground, because you need to be thinking about the orientation of the house, think about those obstructions that could be there. So we require that an early design assistance meeting happens up front, and we have funds to help pay for that. Now the home itself, this is kind of the meat and potatoes and dessert analogy, where you want to eat your meat and potatoes first, and then you have your dessert afterwards. And so the meat and potatoes is the efficiency of the home. And the idea is you want to get the home as efficient as possible and then offset with the solar, the dessert. What you don't want to do is not build a very efficient home and then have to oversize your solar system and compensate for that high energy usage. And the last thing is that you have that installed solar system offsetting all the load. And then I mentioned this before that gas homes can participate, but we just want to make sure that they're also at that efficiency baseline. So it's an efficient gas system before you install solar. I'm not going to read through all of this, but just going to leave this up for a second to give an idea of what the incentives are for those that are participating. They range in the efficiency, that's that first row, about $1,000 to $5,000 per home. So that's for the meat and potatoes. That's the core of what you need to do to build an efficient home. On average, we see homes kind of right in the middle of that, built in the Bend area. And then we add on another $750 for net zero, and then pay specifically for those early design assistance meetings. Now, in addition to that, those that are participating and installing solar, there's incentives that are specifically tied to the size of the solar system, which is relevant based on how big of a system you're installing. And also always call out that there are federal tax credits and sometimes state tax credits or rebates available for installing solar. Now, the same thing for Energy Smart Home. It's the same base requirements where you need to be participating in the program with a qualified utility. You need to have space and cooling equipment that's controllable. And in this, there's a little bit more flexibility where you don't actually have to have the solar system installed or have an electric vehicle charger installed. This is getting the home ready for that decision for the home buyer to install those things later. So these aren't contingent on each other. You don't have to be net zero to be an energy smart home. And I'll talk about the incentives for this just a little bit. Again, won't read through this, but you'll see there's a list of varying incentives that are there that are kind of additive on top of each other, where you can get paid more money for going further with your efficiency, and then also going further with what we really feel like is going to be kind of the future of smart homes, adding in all these technologies that are designed to be ready for kind of grid utility events. So that was my really brief overview. We have some resources, and I think Lindsay probably share out these slides, or they're available on the website if you want to click to these and research them a little bit later. And then I'll stop sharing because that was all I wanted to get out there to start the conversation. I know some of the folks on this call are already in this space doing this kind of work.
Great, thanks, Scott. Yeah, we'll take that a step further and engage with some of the local experts who are utilizing these programs. So if you all have any questions on the technical side or what it's like to use them firsthand, we'll have a great, we'll be able to answer a lot of questions, I hope, tonight. I want to kick off with Jacob Clark from Ben Redmond Habitat for Humanity. Jacob, could you introduce yourself and talk a little bit about why Habitat has made a commitment to build zero energy homes?
Absolutely. I'm Jacob Clark, as Lindsay mentioned, with Ben Redmond Habitat. We have decided this year to try to pursue 9 net zero cottages. And for us, it was kind of the next step in progression of what we're building. So our current build tactics already get us to 3 air changes per hour at 50 pascals. And a lot of our processes are already in place to implement efficient corners, efficient T-wall intersections. So a lot of that EPS construction practices. Part of what the next step we were waiting on was the finance part of it. As a key part, it was important for ETO to allow us to continue to lean on the incentives for EPS construction while pursuing the incentives for zero energy on top of it. So stacking incentives is a big part of affordable housing in Central Oregon. And then certainly the relationships with the verifier, in our case, it's Earth Advantage, Matt Douglas, and solar installer Joe, who is here as well with Sunlight Solar, they've just been excellent partners with us in the past on projects, and have been able to assist us walking into this process. So, as well as partners like Northwest Aerobarrier and Peter and Mike on the call as well, really helping us hit that efficiency mark so that we can keep our roof size minimal and be able to fit enough panels at the same time. So for us, it was just the next step in our journey as it panned out to, and finances were a key part, and they seem to work out this year. So
great, thanks, Jacob. And Perry, we'd love to have you introduce yourself and tell us a little bit about your business and why you choose to also build to net zero standards.
Sure. Perry Brooks, I'm the partner in NZ Development, which is short for Net Zero Development. We are builders of net zero homes and single family and multifamily homes here in Central Oregon. Kind of how I got into doing this is I went to architecture school, graduate school 23 years ago with the intent of graduating and doing sustainable single family home design. And my career kind of took a weird path in the road. And I ended up working in the public service realm for the last 23 years, and decided it was time to kind of come full circle and build net zero homes. One of the reasons why we are building net zero homes, I have several friends who are builders up in Seattle who also build net zero homes and are very successful at it, have a lot of fun, and it's very rewarding. Another aspect of it is knowing that the energy code is changing within the next couple of years, we wanted to get ahead of that a little bit and get some experience under our belt so we can be on the forefront of net zero development in Central Oregon.
I'm glad you added in that piece there that it's fun. We had this conversation last night and somebody was saying, like people just don't want to talk about energy that much. It's not that much fun and not sexy. And I was like, you're not hanging out with the right people. It's really fun to talk about.
Right.
Yeah.
Exactly.
And Peter, let's hear a little bit about what you do with Aerobarrier. And I'd love to hear why you and your partner started this business and how you feel like you're helping the building industry grow here in Central Oregon. Well, I guess across the Northwest.
Yeah, thanks, Lindsay. So my name is Peter Grube, and I am co-owner of Northwest Aerobarrier. And so at Northwest Aerobarrier, we believe that better buildings matter, and matter for people, matter for the economy, matter for the planet. So our journey has been in sustainable building, and we realized years ago, so net zero building, just for the audience out there, is not some brand new, just happening right now thing. Like net zero building has been happening in Central Oregon for at least 10 years that I know of, that I've been involved in. So it's out there, it's doable. We learned early on that a key piece to making net zero building affordable was the air sealing piece. So not wasting energy leaking out through the building envelope. We did that through an energy modeling process, and it turned out that with all the measures we could take, the simplest, most cost-effective, most beneficial was just getting our air leakage down. So that started our journey, and then we came across this kind of new technology to replace the manual techniques that we've all been using up to this point with an automated system that uses physics to just identify and seal air leaks really quickly and really cost effectively. So that's the short version of our journey to this point right now.
Right. All right. And our last, well, I guess we have a few more experts, but I'll have Joe go next and introduce yourself and who Sunlight Solar is.
All right, thanks, Lindsay. My name is Joe Mazzerella. I do system design, project development for Sunlight Solar. Been with Sunlight for about 9 years now. We've been around since the late 90s, or Sunlight Solar has, started by Paul. And we're out of Central Oregon. We also have office in Portland, Colorado, and a couple back east also. But I mostly focus on Central Oregon, and we've been working with a number of builders. Well, a small number, but it's starting to grow, which is really great. Seeing some local builders like these guys here, especially, but start to try to make their homes net zero, and you all now know what that means. And so, in order to do that, you do need to produce your own energy on site, and solar tends to be the best way that anybody's figured out how to do that. So
Right.
that's it from 30,000 feet, I guess.
Yeah. Okay. And Mike, I wanted to have you share a little bit about your process being a homeowner, building your own home, but also you wear the other hat of actually being a green builder too. So could you tell us a little bit about why you decided to build a zero energy home, and what were some of the things that you knew you just had to incorporate since you have such a deep depth of knowledge in this field?
Yeah, thank you, Lindsay. Well, the reason why I decided to build our home, a net zero home, is that's the same type of building that I do for everyone else I build for. So, and that, which is to have a efficient, healthy place to live. But I think the key is we've been doing this as a standard since we started. 2010 is when we started building, and it's how all buildings should be built. And I'm just joined this group so that way we can get a little more awareness so that everyone else could jump in. Water's fine. Come on in.
Great.
Yeah.
All right. I want to jump into one of the big buckets of the design of zero energy homes, which is looking at the building envelope. And Perry's doing something a little bit different with his home than we've seen on most homes here in Bend. Perry, can you tell us a little bit about your project and what makes it unique?
Yeah, we've built this single family home in ADU using SPIS, which are structurally insulated panels. The reason we chose to do it is that it creates a very high performing interior space, which, as you've heard, is important. So we have little or no air leakage. We did also use Aerobarrier. I believe that when we started, before we tested the house, before we used the product, we were at a 5.5 ACU, and then we got it down to a 0.6 on the house and a 0.3 on the ADU. We also came to the decision to do it because it really turned out to be cost effective. It was comparable to lumber package, and just a lumber package, not actually insulating and sheathing it. So it was really a financial decision as well. But again, it really goes back to creating that high performance interior space.
And how quickly did your house go up when you built it?
Pardon me?
How quickly did your house go up when you built it with this?
We literally, I believe if we had a full crew of 4 people there or 5 people, we could have had the house and the ADU with the roof on in 3 weeks. It took us a lot longer than that because with COVID and a lot of other things that were happening, my business partner and myself were doing some of the walls, and we had the second floor walls of the house up in about a day and a half. And so the whole house went up but in about 5 weeks, and we could have shortened it significantly if we had the proper manpower.
Yeah, it was really cool of that, and you'll be able to see it in Perry's site tour that we'll be posting later today, how quickly the ADU went up as well. It's a pretty cool process. And while this is pretty unique, it's really great that we actually have 2 people here on the call who are working with panelized construction. And this is something newer that Habitat's going to be working with. So Jacob, I was hoping you could share a little bit about what Habitat is up to and why you decided to take this route.
Sure. You know, permitting in Central Oregon is complicated. So what we have found is being able to pre-build walls in a modular wall construction process allows us to stack our timeline a little bit. So while we're waiting on some permits, we can go ahead and build. We may be able to stack 12 to 15 2x6 walls on top of each other, laying them flat. And we came across a warehouse space on our property that we were able to save some money by building ourselves rather than leasing it out. So kind of the culmination of having access to a covered space and having volunteers in a controlled environment in the winter or when it's hot, you know, we have fans. It's just become kind of an easy way for us to, with low overhead, be able to manage the construction of volunteers utilizing power tools and things like that. So it's become part of our process for a variety of reasons, but primarily timing, being able to shorten the construction schedule by taking all the walls out for a house and standing them up in one day because they've been pre-built has been a plus.
And by saving on some of that timing and holdups within the permitting process, it frees up some resources too to invest in these zero energy homes. And so getting innovative with figuring out how to make all the pieces work is definitely a forte of Habitat's. So Mike, what kind of practices does Dream Home incorporate to make high performance envelopes in homes? You're muted, Mike.
How about that? I probably sounded better. So we have a little different building envelope as well. We use exterior insulation to give us a complete thermal break. So there's zero thermal bridging. If you don't know what thermal bridging is, maybe Google it, probably do a better way of explaining it. But so there's no thermal bridging kind of at anywhere, foundation, walls, or roof. So that's kind of one of the first differences that we do. And then the second is we use Aerobarrier to get really, really tight. So we go for better than passive house on all our projects. So all of our projects we use Aerobarrier to get nice and tight. And those two basic principles is really the kind of meat and potatoes of our system is no thermal bridging, really airtight. And then along with that, I guess I should mention that we use ERVs on all our buildings. We can do a HRV as well, but balanced ventilation on all of the buildings. Once we get that tight, you have to ventilate, and balanced ventilation is definitely the best. And that gives you an opportunity to filter the air that we breathe inside of our buildings. And as the last couple of weeks proves, that it's actually a pretty important thing. So you want your building tight and filtered air.
Great. And then Peter, you're really the thread that ties all of these projects together, because everybody here is going to be using Aerobarrier on their projects to get that really well-sealed envelope. Is there anything else you want to add about Aerobarrier, or maybe you could tell us a little bit more about why a well-sealed envelope is so important?
Yeah, I appreciate that. And we have had the honor and to work with a lot of the cool cutting edge projects here in Central Oregon, as well as around the state. There are for the record, there's a lot of ways to get a home tight. So Aerobarrier is, we think, a pretty innovative way. It eliminates a lot of the problems we've had in the past, but there's all kinds of ways, from DIY to like exterior products. There's all kinds of ways to do that. Aerobarrier, we feel, is super effective. But the reason it matters, so in a home, every good home that's going to last and be durable, the important thing is to take care of your 4 control layers. So without getting too geeky on this, as much as we think it's exciting and sexy in this group, but so if a house is going to last, it needs to have bulk water control, air control, moisture control, and thermal control, and in those orders. So that's the order of risk, the order of impact to the building, what will make it, deteriorate quickly: water control, air control, moisture control, and thermal control. So that air control, if you're able to stop air leakage through the building envelope, that uncontrolled air leakage coming in and out can carry energy from the inside that you've paid to make. So your heating or your cool, it carries it right out through the leaks. If it's smoky or you have allergies or contaminants outside, that air can leak right back in. It carries moisture into the walls. That's the start of mold, rot, all kinds of issues. So if you want to have a home that's healthy, that you're breathing filtered air and ventilating well, if you want to have a home that's comfortable year round, you don't have drafty spots, you don't have cold rooms, hot rooms, all of these things matter for stopping the air leakage and controlling that air barrier. So that's our specific focus, and that's why we think it matters.
Great, thanks, Peter. Yeah, and this really comes back to part of this reason why zero energy building is so important when you start to think about all of these issues that Peter was bringing up with the durability of homes and how much longer they're going to last. So when you start to think about the lifetime costs of making these kinds of improvements, they really start to add up when the home lasts longer, from a health and performance piece and from an environmental piece of not having to build new homes. So it's really important all around.
Yeah,
I had a question. Oh yeah, Peter.
I was just going to say, I was trying to respond to someone who asked a good question in the Q&A, and I shouldn't try to multitask. It's bad. My brain.
That's okay. I was going to bring some of those up. You go ahead and take it away.
Yeah. One legitimate concern, they're talking about the cost of land and how do you even get to build around here. That's not really in the scope. That's a legitimate concern. And we're all struggling with it, from habitat to custom homes to production builders. We're all struggling with that. Not really in the scope of the net zero. The point I did want to make is how do we build net zero affordably? And I was trying to get the point across that when you get started right away, no matter what you're going to do in a project, you have to have goals and priorities that you set up. The easiest way to make net zero cost effective is start right off the bat as one of your goals is this house is going to be net zero energy. So that will affect your design, your size, all these other decisions, so that if you have a budget to build with, whether your budget is $300,000 or $3 million, you set that goal that I'm going to use my budget to get to net zero. And in that way, building net zero is the same cost as building anything else. I couldn't write that to that person quickly enough. So.
No, that's fine. I was just about to bring that up. And then Scott, I'm hoping that you might be able to help us out. We had another question coming in just asking where to start when you want to build zero energy. Do you have any tips and pointers there?
Well, I will plug Energy Trust website, of course. There are builders and contractors on this call that could actually just give them a call and they can build you that house. But Energy Trust does have a builder and verifier lookup, and so you could find qualified contractors in your area. What I'd add to that is taking out the guesswork of net zero. Peter called out that net zero is not a new concept, builders know how to do it. And now we have the tools and softwares to be able to take the guesswork out. So you really should understand if your house is going to be net zero long before you're doing any construction. So we have modeling tools. We'll estimate your usage, and then you can estimate how big of a solar system you need. And what you know as a home builder or home buyer or owner is how are you going to operate that home? And so all the things that aren't considered unless you actually have intimate knowledge about that home, like do you want to put a electric vehicle in there? Do you want to get a hot tub? Do you have a lot of TVs? All those things you can factor into how much generation do you actually need, so you get that zero energy bill when the time comes.
Great. And then Joe, I'm hoping we can follow up a little piece with this question of where to find land, which is definitely a tricky conversation and a hard conversation here in Bend. But if somebody is looking to buy a piece of land to build a home on, what are some of the things that they might want to look for to make sure that it's going to be a good site for solar? Because I know one of the hardest things to tell people is that their home doesn't qualify for solar because of their existing home doesn't work. So if you're building a home, what do you want to look for on your lot?
Right. No, that's a good question. You know, really, we get a lot of trees around here and they're nice. But if they're directly south of where the home site's going to be, that can be tricky in making it work. Shade's great, but it can kill your solar output pretty quickly. So you really want to look for to the south, having a good open window of sun for most of the year between, 10 and 2, 9 and 3 is better in the day. I have an instrument that I can even go on site and we'll measure your solar access, and basically I can show you what trees might need to go. A lot of times if you're building a new home, you know, some trees have to go anyway to clear space for it. So that's something you want to look for is, you know, and a lot of people, you know, go out there in July and say, what do you mean? My house gets sun all day. It's crazy. And yeah, in July, but you got to look year round. You know, the winter months you're going to produce less anyway, but you do want to have some solar access in the winter too when the sun is low. So that's something we can do for you most of the time, even just on Google Earth and take a look and say, well, you know, but a lot of times it helps to get on site.
Yeah, and I know you've been known to go out and get on top of a ladder and hold instruments up to try to figure out what the shading is going to be up on the roof of the house. And so I think one of the really key pieces here is that you want to identify that as a goal early on so you can prioritize it. But you also want to get the experts engaged early because there are people who know what to do. So if you're just starting and you have this big idea and don't know where to start, you can call somebody on this call or just ask your designer or builder, have you done a zero energy home before? And they should be able to help you out right from the beginning with all of those steps in the design process.
Yeah, that's right. And also a south-facing roof does help in the design. East and west will work if they're not super steep pitch, but it is best to have somewhat south-facing roof.
Great. And Peter and Mike, I know you were both trying to chime in there.
Oh, sorry.
Yeah. I just wanted to say, advise, you want to get your designer and builder on this together before you design.
Mm-hmm.
Get the designs together. That's extremely helpful.
Yeah, and Energy Trust has an incentive to do just that, to get the solar contractor, the builder, and the designer all together, because that's a really key piece to make sure everybody's together beforehand.
Yep.
Is that the early design incentive,
That's the early
Scott?
design assistance. Yeah, they mentioned before. Yeah, $500 per design.
And to be clear, Energy Trust pays you $500 for all this beautiful assistance and modeling and everything. It's not $500 you have to pay them. It's an incentive to do it. So.
Yeah.
Good clarification.
Starting early is important.
Getting paid anything for any customer.
Yeah. And we have some local representatives who are able to, that are boots on the ground here that can meet with you in person and help you out with that too. So we'll send out all of that information afterwards so you can all get connected. All right, so we talked a little bit about the envelope, another key area of design, which I think some of you have alluded to, is looking at the some other key pieces of technology and the mechanical systems in the home. So this house is a system, and everything we want to be working together and be using as little energy as possible. So Jacob, I was hoping that you could tell us what are some of the key features that you utilize to get to zero in your all electric homes?
Absolutely. It's kind of all a jigsaw. So one change affects 4 pieces away, sort of thing. So we were able to develop some land as a way to save on cost of land, and modular build walls in a warehouse as a way to stack processes to save costs. And at the same time, we've started using heat pump water heaters as an option for our all electric net zero homes. That early design assistance meeting was key in bringing HVAC installers and sheetrock insulation contractors, bringing everyone to the table so they can know when processes need to be implemented. And that early design assistance meeting determined some pretty significant mechanical changes down the road. So from mini split systems, like Mike mentioned, having a balanced system. If it's 2 stories, are we going to do ducted systems in the building envelopes? Are we going to do mini splits, or what is that really going to look like? And that early conversation changes many of the mechanical variables. So whole house bathroom fan, or are you going to do an ERV or HRV system of some sort? I think timing, deciding early on, is the key takeaway from all of it, for sure.
Great. All right, there are so many things I want to follow up on in there too. This is all really good stuff. Scott, I was hoping, could you give us a quick overview of why putting the ducts in the conditioned space are an important factor with zero energy building?
Sure. Yeah. So if you think about just kind of the biggest bang for your buck, Peter and Mike talked about air sealing. You don't want to have any type of heat loss or cooling loss. And one of the biggest, riskiest place for that to happen is in your duct system. You think that that's going outside of, the envelope of your home, and it's going into, somewhere else in the attic. And even though, homes are required, not all of them, but our program homes are required to be sealed a certain way, there's room for error there. And the leaky ducts leads to basically a lot of energy loss. So bringing your ducts inside of the envelope and your HVAC equipment inside of the envelope basically minimizes those losses almost entirely. And the challenge that we hear about that is really about a design thing, because you're not taking that HVAC installation and you're moving it up to the framing discussion. And so that early design assistance meeting, like you need to understand how that's going to work up front. Otherwise, you're going to be stuck with ducts that are too big to fit inside the house, when you need to come up with something else. Some other options too are using kind of non-ducted heating systems like ductless heat pumps, or kind of spot heating systems. Those have worked too to kind of maintain it all within your envelope.
Great, thanks. Yeah, and when we're talking about the envelope here, we're talking about the space inside of which you want to condition and heat and cool. So a lot of people will not include their attic or maybe some knee wall areas or crawl spaces. So it's the space that you actually want to control. You want all of that heat loss or air cooling loss to stay in within that conditioned space, and that's the envelope that we're talking about. All right, and then Perry, I know that you also had some other cool features to your all-electric home. What are some of the ways that you were able to get to zero with new technology?
Sure, and we utilize a lot of the systems that Jacob and Scott had previously mentioned. Heat pump water heater, ductless heating and cooling. We have an ERV for exhaust and makeup air. But the one thing that really stuck out and a lot of people are questioning is the induction stove. And the induction stoves have come a long, long ways. And they actually are better at cooking for controlling heat than gas stoves are. And I think that was that was definitely one key component to it, but it was also the most challenging to sell to people, not really understanding how the induction works. Everybody has been used to seeing induction stoves from back in the 80s when the surface got super hot and you couldn't touch it for an hour afterwards. It's definitely come a long way since then, but that was definitely a challenging piece to an all-electric house.
And another great benefit of induction stoves is that once you get these envelopes as tight as we're talking about, you want to be really careful about any contaminants that you bring into the home. And a lot of people don't realize how much we bring into our home with VOCs, with our cooking and our water heating and all of those gas appliances. So it's just another way that you're enhancing that indoor air quality in your home and making it healthier for everybody in there too. And Mike, I'm super excited about the system that you're using in your house. Can you tell us a little bit about that?
Yeah, so for our water heating, we're going to get a Sanden heat pump water heater. And the difference about this unit than most heat pump water heaters is that one is that the condenser is separate from the tank. And so it's got an outdoor unit, kind of like your mini splits might. And so that's where the heat is generated. And so that does two things that's pretty cool is it makes inside the house really quiet. Like you don't have one of the two negatives that most heat pump water heaters have is that they're fairly loud. So you need to be aware of where you locate them in the house. And the other issue with a heat pump water heater is that it'll make the space that it's in cooler because it kind of takes the heat from that space. So this system, those two things occur outside, and so it's really quiet and doesn't change the temperature. And the other cool thing is it uses CO2 as a refrigerant instead of other synthetic refrigerants. And so that's huge for global warming. It's got very low global warming potential as opposed to the synthetic refrigerants. And so it's the low global warming potential along with it being super, super efficient. Those are the two main reasons why I decided to use it. And it is pretty new technology. And so there's some learning curves. We weren't sure who would install it. Does a HVAC person install it? Does a plumber install it? Is it a mix of both? The answer is actually the plumber installs it. It's mostly plumbing, and then there's electrical connection that an electrician would make. So it's actually a lot simpler than I first thought. So I'm really looking forward to getting it installed and using it.
Awesome. Peter, you look like you have something you wanted to say there.
No, I'm trying to multitask again and answer someone's question.
All right, great. Yeah. So with the Sanden system, it sounds counterintuitive because CO2 is in the name, and we all think of that for global warming and climate change.
Yeah.
But really, the refrigerants that are used in a lot of heat pumps are actually even worse and are one of the largest emitters and have the biggest global warming potential. All right, Scott, was there anything we missed there that you wanted to talk about with other kind of key technology or things that Energy Trust incentivize that can help you get down to zero?
Those are the big ones. I mean, really getting your home tight and keeping your ducts inside. If you are using a ducted system and it works on the system you choose, getting a thermostat that's controllable, a smart thermostat. There's additional money from Energy Trust. They look really cool. You can do other things with them, like, turn them on and off with Alexa or your app, and they play music. But they actually have been proven to save a good amount of energy. Things like the Nest and Ecobee. I've had both in each of the last two houses I've been in, and they're wonderful for how much they cost. There's a lot of savings there.
For new and existing homes. So that's a really great tip for existing homeowners to look at how you're controlling your heating system. And there's incentives from Energy Trust as well to help you bring your heating costs down. All right, we had a question come in asking about what it costs to use Aerobarrier and what that looks like.
That's the one I was just answering when you caught me off guard.
Oh, sorry.
So yeah, good question. The kind of quick down and dirty answer is about $1.50 a square foot for conditioned space of the home. That's our general retail pricing, but I encourage the person to reach out to us because it does vary on the complexity of the project, what phase we're going to seal, what their intentional air barrier is in the home. And if, like everyone else, if it's a production builder, it's different than if it's a one-off, and it's different if it's small or if it's big. But for argument's sake, if you're budgeting or trying to compare it to other options, it's about $1.50 a square foot.
Mm-hmm. And compared to, I've heard even today, somebody talking about their manual air sealing as a painstaking process that can sometimes take weeks to get down to the numbers that Aerobarrier is talking about. So it's just something to compare against other methods. But as we talked about, having a really good seal on your envelope is something that's going to pay off for many, many years to come with the durability, comfort, and health inside your home. So it's really something important to be looking at in the process.
Yeah, I was going to say, kind of our origin story of getting into Aerobarrier is we have tried everything else. I don't think there's much we haven't tried going back to EcoSeal and crawling around on our hands and knees with foam and caulk and tape systems, all kinds of spray foam system. We've tried it. And so that's where we ended up as professional builders. There was no better way to do this. I think the only other better system I've heard was from Jacob and Habitat, where they would have wonderful, kind-hearted volunteers who, when they needed to keep them busy, they had them walk around with caulk and foam and just seal houses up. And I had a fun chat with Jacob's predecessor, who was an awesome project manager and woman for the company. And she's like, yeah, can't beat that.
Yeah. Yeah, you can give volunteers 24 tubes of caulk and it goes a long way.
So unless you have 24 volunteers ready, and we've talked to people, like we have this conversation a lot. There's a lot of ways to air seal. If you're a homeowner and you want to do this yourself, and that you can definitely get a house tight. But I challenge people to find a faster, more consistent, more replicable way if you're doing it professionally to get your envelope tight. And the other big difference is all the manual techniques we've tried, you don't know where you are. You're kind of spraying and praying, or you're guessing, or you're just taping the heck out of everything you don't really know. So with Aerobarrier, it's being installed with conventional blower door technology that some people may be familiar with. So not only is the blower door driving the sealant to the leaks, but it's also measuring as it does it. So we know in real time how tight we've gotten it. And we're also able to diagnose if there are significant issues in the envelope that somehow have been missed or hiding. So those features together make it pretty powerful.
Yeah, and when it comes to air sealing too, this is just such an exciting thing, and I swear this just isn't a sales plug for Aerobarrier, but air sealing in general. That I know Core Community Land Trust, who we'll hear from tomorrow, will take a deep dive into their affordable zero energy project. When they put Aerobarrier into their modeling, they were able to decrease the size of their solar installation because the house became that much more efficient. So it's a really important piece to be thinking about, this idea of eating the meat and potatoes or the conservation veggies before your solar dessert. And it's really important to reduce the load first, because then you can also install a smaller solar system.
Or, as we have Joe here, you could install the same size solar system and you could power one vehicle and your house off the same solar.
Exactly.
Right, Joe?
That's correct. And I want you to start calling me solar dessert now.
Yeah.
All right. But unfortunately, a lot of people don't have room for dessert when they get to the end of the project. But that's why it's good to be involved from the front end to make all this happen.
So it's not just the size, like not just making it smaller. Like for Core, that helped a lot.
Right.
It's also the matter of, you may have the scenario where the energy model tells you, if you haven't built a good enough envelope or you haven't made wise selections with your appliances, your heating and cooling system, you may not physically have the room on your roof to put enough panels to make it
Mm-hmm.
And that's
so maybe more a matter that you can actually get
Yeah.
there as opposed to getting a smaller array.
And
Yeah.
that's true. And I think it's if you know, you guys are making these really efficient homes and everything, and I think it's awesome. So you know, if we're installing smaller systems to make net zero, I think that's great. I mean, more people want to do it, you know. And a lot of it is on the front end, like you guys said, the early design assistance meeting, getting some energy analyses, and a lot of times that they get narrowed down as it goes on and as they start making decisions. And if you end up with more solar than you need, and then maybe you get that hot tub, who knows, or that electric car, like you said. So.
Yeah. Okay. So then I do want to just do one more question about solar before we start wrapping up here. Because if you can't add solar at the beginning of the process, you can also build solar ready. So Joe, can you tell us a little bit about what solar ready is and what it might look like when you go to add solar onto your project afterwards?
Yeah, sure. So making it solar ready is basically, like I alluded to before, a lot of times at the end of the project, maybe it's not in your budget, or it's just not time to do it. So, but on the front end, you should at least and can pretty easily make it solar ready. What you need to do is identify the solar roof, and generally it's south facing. Sometimes east and west, like I mentioned, work well too. On occasion, you get a north facing roof to work with a tilt up, or if it's very low angle. But identify the solar roof, and then you end up working with either your electrician or a solar contractor to install conduit. It's called a rough-in or a pre-wire, where you run conduit in the walls down to where the interconnection is, and say from the solar roof. If you have attic space there, you don't necessarily have to penetrate the roof. If you don't, like vaulted ceiling, you're going to need to do that. And then a lot of times just having your electrician provide a 225 amp panel instead of a 200 amp panel. Cost them probably about an extra $25, and just having that extra capacity there. So if you did want to install a larger system later, your electrical system can interconnect and it works well. Really call a solar installer and they'll line you out, and talk to your builder also on the front end. But that's basically it. I mean, then they know you want it solar ready, they know not to try to put plumbing vents in your south facing roof, or if there's gas there, a gas B vent. I mean, those things can really eat up some valuable space there.
So again, really important to make that goal known up front so that everybody's working toward that same common goal at the end. I see all our panelists saying we're gonna have to pull the plug to make you all stop. I know that you all are passionate about this and can go all night talking about this stuff. So I'm going to start to wrap up. Well, I'm going to open it up and see who can get here first to see if they want to add a closing comment while I pull up our last slides. We'll send out a follow-up email. So if you all have any other questions, feel free to reach out to us and we can answer it in that email, or let me know and I'll get you connected with all of the experts. All right, y'all ready, set, go. Who's going to get the last pitch in there?
Built homes are barely legal homes, so it's too low of a bar.
I would also add, in Oregon, we have such a resource of knowledge with ETO and providers like Joe and zero energy builders, that we all just want to get it out there. Even if you don't have, graduate degrees or 20 years experience, that knowledge is here and we would love to share it. So I think Oregon has a huge resource of information available.
Yeah, I'll add on to that there's training, so keep an eye out for those things, like actually in-depth trainings on how to build net zero homes. I think Earth Advantage was mentioned, Jacob, earlier, so keep an eye out for those kind of things, plan ahead.
All right, and there is a training coming up with one of our partner organizations, Earth Advantage, for builders who are interested in learning more about this, or designers, or even just curious community members as well. All right, I see that there's a question in here about windows that we'll try to follow up with in our follow-up email. So again, we have a few more live virtual events left this week. If you want to take another deep dive into zero energy building and affordable housing. We'll be chatting with CORE's whole design team tomorrow evening at 4 o'clock. You can also tour that site live and in person. I know this is a virtual tour, but we have one site that you can visit in person. It's still under construction, and you can sign up for appointments because they don't want too many people on the site all at one time. So you can find a link to that on our website. And we'll be releasing all of these sites, so you'll be able to get a behind the scenes look at Perry's site and Mike's site as they were being built, and learn a little bit more about their construction process. And we look forward to doing the same with Habitat soon, once they get more of their process rocking and rolling too. So we'll be able to see behind the scenes on that as well. So thank you again to all of our panelists here tonight. We'll connect you with all of them if you have more questions. As you can see, everybody here is really passionate about getting this information out, and we love to talk about it and share it with the community. Really, if we're going to make a difference when it comes to climate change in our community and reach the goals that are set forth in our climate action plan, we need to be building better buildings and all talking about this, and it needs to start right now. So hopefully we can take this conversation forward and keep disseminating more information and building more healthy and affordable homes for everybody here in Bend. All right, so we hope to see you at more events. Let us know if you have any other questions, and we'll try to get to the bottom of as many of those as possible. All right, thank you everybody, and have a great night.
Thanks, Lindsay.
Thanks, everyone. Thanks, Lindsay.
Thanks, Lindsay.
Everybody.
Thanks, everyone. See you.
See ya.